So let's start here. So how many people here have used a smart TV to watch Netflix? Okay, what about a set-top box, like a Roku or something like that? Okay, how about maybe a cable box or Blu-ray player? Okay, so those are just a few examples of some of the many devices that Netflix runs on. So just to give you a little bit more detail about that, we work with over 350 different device partners in order to get the Netflix app on all these different devices. So this is just a few of them, but many of these partners are going to have multiple different devices. So building on that, that's going to give us about 1,800 or more different devices that the Netflix app is running on. So I don't know about you, but I have a hard enough time getting a website to look good in Internet Explorer in the different versions. So I don't know, 1,800 different devices, some low powered. It's a little bit crazy. So how do we do that? How does that happen? Just one small way that we can make that happen, or one small piece of the puzzle that we can do to help that, is to improve the developer experience and enable automation. So one way we're doing that today is through a device like this. So that's what I want to talk to you about today. It looks a little bit like a router. But this is what I'll talk about today. If anybody wants to look at it, feel free to pass it around. So just to give you a little bit of info on sort of the impact that this has had on our testing and how it's affected our business. 30% improvement. So we were in China visiting one of our device partners, and we were out to lunch, and one of them just said, you know, this thing is great. It's been about a 30% increase in our productivity. You know, so it's obviously an arbitrary number, and it's totally made up, but I wanted to share it with you anyways.
No names or anything, right?
No.
You're not going to give us.
But okay, so let's start with a little bit of background and talk about how we ended up here. So scaling the Netflix app to 1,800 different devices. So there's two main ways that you can get the Netflix app on a device. One way is through in-house development, and some of the examples of applications that are built in-house would be common platforms like the iOS app or Android app or web app. And then there's another set of devices that are partner devices. And those devices use an SDK to implement the Netflix app. And so we give the partners an SDK, and then they go ahead and implement that app on their device. So having said that, with all these different device partners integrating Netflix onto their device, there's obviously quality concerns there. So we want to make sure that we can continue to deliver the same great experience on all of these different devices. So how do we ensure that? One way that we ensure that is through our certification program. So what that is basically a program that a device manufacturer has to put their device through before they can release that device with the Netflix app on it. And so what that looks like is there are hundreds of different test cases that have to run against a device in order to get it certified. There are different tests like performance-related tests, security tests, playback and rendering tests. So there's a lot that goes into this, and wouldn't it be nice if we could automate some of that? So for the past few years, we've been using something called Netflix Test Studio, or NTS. And this is a cloud-based testing tool that we use to test these devices. So you can connect your device to this cloud-based testing tool, and then you're able to easily run tests from a web UI. And so this is used by engineers that are implementing the app. It's used by certification engineers, QA engineers. So it's used a lot throughout our company as well as at our partners' sites. So just a recap on that. So the partner receives the SDK. They implement the SDK on their device. And then they run NTS to look for any bugs, and then they repeat that process until they feel like they're ready to submit for certification once they're passing all of those tests. So then we'll do the same thing internally. We'll run all of those test cases on this device, and then we'll give it the stamp of approval if it passes everything. So this is responsible for a lot of the progress that we've made in order to get all of these devices running the Netflix app. But of course, there's always room for improvement. And going global put a little bit more pressure on that. So we are now available worldwide. So now we're working with more partners across the world, which means more devices and more testing. So naturally, we looked for ways that we could improve this process and become a little bit more efficient. So some areas for improvement, I'm going to talk about 3 key areas that we found that we could improve on. So number 1, setup was not easy. On one of my first days here, I asked a teammate how to get Netflix Test Studio set up for my device. And he said, okay, so first you have to go to IT and order another laptop. Then you have to download a virtual machine and install that virtual machine, download VMware. Then you have to go order this USB to Ethernet dongle because we don't have any more. And then you connect your device up to that. And then once you've connected your device up to that, if you want to connect more, then you can do this process all over again. So it was difficult. And once I was underneath the table, this is me, by the way. Once I was underneath the table covered in Ethernet cables, I said, this is crazy. There's got to be a better way. We can do better than this. So that's number 1. Number 2 is we had a variable test environment. So every setup could be drastically different. The hardware that they're running that VM on could be totally different. It could be a different OS. It could be different software running on that device. Their network configuration could be totally different. So it was a total mystery to us. And that makes it difficult to reproduce bugs. And of course, that means it's difficult to debug issues and figure out what's going on. And number 3 was manual tests. So the majority of our test cases are automated, but there's still a big number of them that require human interaction. So, for example, there might be a test case where you need to start the app, stop the app, turn off the device, turn the device back on, start the app, stop the app, do all this. And so you need to babysit this test and wait for your cue to hit a button. So obviously we would like to automate that. I mean, if we can automate that, that would save us a ton of time and people don't have to babysit these tests. So our solution to all of this is what we're calling the reference automation environment, or I'll probably be calling it Ray throughout the rest of this, or I might be calling it by its old name. Who knows? We'll see what happens. But what is Ray? So Ray is a hardware platform that enables automation of devices, their environment, and their network, and the applications installed on them in a reliable and consistent way. So that sounds a little bit like a sales pitch, kind of like I'm pitching you my startup or something. So let's dive into that a little bit. So enable automation of devices. So the way we want to automate these devices, we want to do that both physically and programmatically. And then we want to be able to control the environment that these devices are running in. So, for example, their network configurations, things like that. And then we want the applications installed on them to be able to be controlled by us. So, for example, the Netflix app, it would be nice if we could control that. And then we want to do it reliably and consistently. So we want to make this environment reproducible, so it's easier to reproduce bugs. So a big question is, why would you use hardware for this? Isn't that sort of a step backward? Shouldn't you just connect everything up to the cloud and that would be way easier? Or wouldn't that be costly? Wouldn't it be difficult to support all these devices if we're giving them to different partners all throughout the world? And my answer to all of that is yes, probably. It might be a terrible idea. Just kidding. It's not a terrible idea. It actually it's a great. It's been great, and there are a ton of different benefits that we can gain from this. So the first benefit that we see, and this is a huge one, is that we have a physical device now which gives us access to the physical world. So think about all of these Internet of Things type of devices or peripherals or sensors and things. Now we have basically a hub where we can connect all of these things up to, and we can aid with automation by using those types of things. So think of a camera, for example. If we connect a camera up to this, we can now use computer vision to test for AV sync issues. And there's an awesome project at Netflix called Electric Eye that does just that, so you should check that out. But another example would be, say, all those remote control key presses. What if we put an IR blaster, so we can simulate a remote control and we can send signals to our device under test? That would take all those manual test cases and turn them into automated tests. So on top of that, we get the ability to collect more data and insights about the testing environment. So we could now maybe test the throughput to different Netflix services while a test is happening. And then if the test fails, we can see what the throughput looked like during that test, and that can help us diagnose a failure. Maybe the test failed because their internet gave out for a little bit. And then it also helps us with setup. I mean, now you just have this device, you plug in your device that you want to test, and you're all ready to go and set up to run Netflix Test Studio. So how it started with a simple prototype, which was some PC Engines hardware, and it's a 1 gigahertz processor. It had a Wi-Fi card, 3 Ethernet ports, USB serial. So it had everything we needed, and then it was running on Debian Linux. So we just basically set it up as a wireless router with some extra features that would allow a device to hook up to Netflix Test Studio. And it was working great. We used it internally for a little bit, and then all of a sudden something seemed to happen. The ideas just started flowing in throughout the company. All kinds of different ideas started popping up on how we could use this and how we could take advantage of having this piece of hardware in between the device and the network. So some things like bandwidth shaping, or IR blaster, like I mentioned, or power cycling a device. Maybe we use a power outlet that, an IoT type power outlet, and we can power cycle devices. There's all kinds of different ideas that started popping up. So then we thought, why don't we make this into more of a platform? There's a lot of people interested in this at the company, so if they're interested, why don't we let them build things that would be useful to them? So for example, those folks that were working on the computer vision project, they could maybe turn that into a module and run it on this device. And it allows us to move faster if it's modular, so we can push updates to small pieces. So this is what it looks like. At the very top level, we have this module system. And a module is basically just a process that's running on the device. And it can be a server or a script. It can be JavaScript, Node, Python, Ruby. It can be anything. And then we have this middleware layer, or management layer is what we're calling it, which is just responsible for managing all of those modules and starting and stopping them and things like that. So it's sort of an admin layer. And then, of course, that's just running on the OS, which is Debian. So here's a diagram that would sort of explain an example usage of this. So if you just look at it, so the first piece to look at is the Ray hardware itself. So that is creating this local network here. So now that we're creating this network, we're now in control of it, and we can control all the characteristics of that network, which is extremely useful for a testing environment. So the hardware has a Wi-Fi access point. It's like a router. It's got Ethernet as well. And so here we have a device under test, which is a smart TV. And that smart TV is connected over Ethernet. And then we also have, just as an example, an IR blaster. And that's connected over USB. So if we look into the software side of this, we have that management layer that's administering all of these modules. And for example, let's say module 1 is the module that's responsible for actually executing test cases. So when that module decides to execute a test case, that requires something like an IR signal to be sent. It then sends a message over to module 2, which is then responsible for talking to that USB IR blaster, sends the signal there, which then controls the device under test. So with that example, we just eliminated that guy that has to sit there and babysit that test case with a remote control. So a little bit more detail on that management layer. So this is what it looks like if you were to log into one of these. So these are all the different modules that are installed on this particular array. So that's what your admin interface looks like. And you can manage all of the modules. You can install, update, remove, start and stop, edit configurations. So it's basically the admin face to your router. Now, the modules themselves, like I mentioned, they're just an independent process or script that can run on Linux. And it's typically a server plus a UI. Some modules don't really need a UI because they're really only interacting programmatically. But it's nice to have a UI to click around and make changes. And then they're in any language, as I mentioned. And then to wrap it all up, we just package it in a Debian package. So that's the basics of a module, and it has a little bit of extra pieces in there just to tie it back to that management layer. So let's see some examples. First example has a fairly common use case for testing applications, particularly on devices. So a traffic shaper. We want to simulate different network conditions. So we can adjust the bandwidth, latency, packet loss, things like that. And this is particularly interesting because Facebook has a great tool for doing just that called the Augmented Traffic Control utility. So we were able to take that and just wrap it up into a module, array module, and give it a little user interface. And now we can easily shape all of the traffic of all these devices. Another one's just more of a diagnostics tool. So this one's great for having an easy way to grab Wireshark packet captures of different interfaces, for monitoring throughput to different services, things like that. Another one, this one's a little bit interesting too. So this was our first contribution from outside of our core team. So our idea for a module system was catching on, which was great. So this is wireless tools. So this came out of somebody that was a little bit frustrated. They had a test case where they wanted to test what happens when a device loses its Wi-Fi connection. So he said, okay, I can build a module where it does exactly that. It controls programmatically the Wi-Fi on this array. This one's my favorite. So this one's a very simple one, and all it is just a script that allows for some physical automation. So it's just a script that talks to this little servo that has a little arm on it. And so we have a device lab here with a bunch of different devices that are used for testing. And the guys in the device lab needed a way to quickly power on a bunch of different devices or power off a bunch of different devices. And since they didn't want to go hit the button themselves, they decided let's use this little arm here. And so really simple, but extremely useful. So now I just want to talk about some of the challenges that we've faced when building this. The first challenge is something that's nothing really new to embedded software, but I think we have a kind of interesting way that we solve this. So we're running Linux on this box, so we decided we might as well leverage the Linux tools that are available. Our modules are already packaged as Debian packages, so we decided in that management layer, that Node app, let's just wrap the advanced packaging tool in Linux. So then, we could add a WebSocket to a UI. So now we have a nice UI with like an App Store type functionality for checking for updates to packages and installing and removing different packages. So a fairly simple solution to trying to keep software up to date on these devices. Our second challenge was security without compromising transparency. So what I mean by that is, how do we secure these boxes without, let me step back. So we have great partnerships with all of these device manufacturers, and we want to give them these devices to use in their network, but then we're putting hardware in their network. So we feel like we should give them some visibility into what's on that device. But we want to do that without compromising security. Like, we don't want to completely unlock it so that they can do whatever they want on it. So it's a bit of a challenge. But the way we got around that is we first just locked down the device. We randomized the root password. And then we generated a unique registration code per array. So now that we have that registration code, you can go to the UI for that particular array, enter that registration code, and then you can log in and get access to different things on the box. So once we set up a login through the UI, we then, of course, realize, well, we can't log in through the UI if we don't have SSL. That's no good. We don't want anybody stealing our registration code. So we needed an SSL cert per device. And we didn't have any domain names for these boxes, so we needed to get a domain name. But then we realized we don't have static IPs either, so how are we going to associate a domain name to these? So that led us down the path of a dynamic DNS service. So whenever there's an IP change, we just send a DDNS update. And in order to do that, we generated an SSL cert at the subdomain level for each ray. So we've got our domain name and then a subdomain for each ray. Now, the request for actually updating that DNS, we are actually using the SSL cert itself as a client cert to sign and authorize that request. And just as a side note, the DDNS server, we're using Lemur, which is an open source Netflix tool for managing and generating SSL certs. And then we're also using Route 53 to do the actual DNS changes. So as an added bonus, then we now have this client cert for each array, and so we can authenticate with our cloud services using that. And we also now have a convenient subdomain, so every array has a nice URL that you can go to and pull up the UI. So moving on to challenge 3, getting contributors. Still haven't figured this one out. Just kidding. We kind of figured it out. But anyways, the developer experience is obviously key to getting contributors. So balancing flexibility with simplicity, I think, is a key point to that. And one of the ways that we did that was through making it flexible. They can write it in any language, but we're keeping it simple by having it packaged as a Debian package, which is a common way to package up software and deliver software. So on top of that, we thought we needed an open playground for modules. We want people to have an easy way to distribute these modules within Netflix and test out prototypes and things like that. So we just created this internal Debian repo where engineers can share their ideas and prototypes and easily deliver that. So the next thing we thought about was security. So we didn't want module developers to have to worry about security. So we tried to abstract that away. And the way we did that was with the management layer, which controls all the modules. We added to that a secure proxy. So now a module, say, has a UI that wants to talk to its server. A module has a UI and a server. What it does is it can talk to the management layer directly over SSL as a proxy and send that request, forward that request on to the module's server. So sort of a middleman that takes care of all of that for us. So what's next for this? So we are considering using AWS IoT for this, which would give us a secure messaging queue that would be tolerant to intermittent connections. Sometimes these boxes are disconnected, but we still want to push a configuration or something to them. So this would help with that. And we were looking to add a messaging queue anyways, and this is hosted, and it's secure actually by using that same model that we're using with the client cert. So we're actively looking at that and looking to implement that. We're looking to implement automatic updates, which is a little bit of a challenge because this box is used for testing, and sometimes it runs overnight. It runs tests for long periods of time. So how do we do these automatic updates without interrupting test cases? And then openness versus reference environment. So again, this goes back to the transparency with our partners and how open we want to be with them about these devices. We want to give them access to do the things that they need to do, but we also need to keep it a reference environment. We don't want to disrupt that whole idea of an environment that we can trust and that is reliable. So just finishing up, so far we've got some really great feedback, 30% improvement. We're coming out of beta with it, and we're starting to deliver it to more partners throughout the world. And partners continue to ask for more devices. So it's so far a good sign, and it's been working very well for us. So that's all I had. One last note is we are hiring. We're looking for another engineer on the team. So if this is at all interesting to you, please come say hi and introduce yourself. But yeah, if you have any questions, I'd be happy to try to answer them.
Yeah, so I was thinking, typically for this kind of test, I mean, you're running a set of commands, and typically, so that's the input and the output for this kind of device test, I guess, would be some kind of success or error code, and possibly also some screenshots of some failure screens. You know, if the test is not getting through. So. Who will be responsible to get this screenshot? It will be the SDK of the device itself, or it could be your web environment that maybe could have a webcam to capture some screens.
Yeah, this is not a bad idea. Yeah, so I don't believe, as far as I know, I don't know of any screenshots that get taken. Oh, I guess I'm wrong. Somebody's shaking their head now. So I guess there are screenshots that get taken. But yeah, so. Sorry, what exactly is there the question there? What was the question there?
Well, it's basically yeah. I was wondering if you guys are trying to extract some screenshots because you know it's one thing to say, oh well, the test suite failed, you know. Yeah, but I mean I was not in front of the TV, so I don't know, because I guess that typically these guys are running on their lab and nobody is in front of them when they're running, you know. So
yeah, so. It sounds like we do have screenshots, but on top of that, there's a lot of different logs that get captured, and you can also take a look at those logs and see more of what's going on.
To further elaborate, it kind of depends on the fundamental nature of the problem which you hit. For specific things around AV sync and latency, where having an external camera makes sense, we're investing time and resources into figuring out how to do that appropriately. But we do know that there are SDK hooks within our deployed SDK to take screenshots of what's on screen at that time. And we do that throughout our test suite quite ubiquitously, depending on, again, just the nature of the failure. But our logging comes from a number of different sources that we all extrapolate into one central repository, and that's one of the another module that we're actually investigating is can we have a central file repository on this Ray environment itself that actually houses all these logs, so that especially if they're rather large, we get actual screenshots, maybe even video, so that they can be transmitted back to home base. At times in which the network bandwidth actually is more prohibited or is less prohibited for these type of things. These are again just types of modules, the ideas around modules that we're kicking around at this point in time to just get a more clear understanding of the failures involved in actually running running certification testing, as well as the environment in which the certification testing is being done.
So, just a couple of questions. First, I don't know how many layers are on this thing. Is there like a scripting language on top that I can just write some like human understandable code, like push the button, change the channel? I mean, that layer, and then, or
Yeah, actually, so within Netflix Test Studio, there's actually different test steps that you can use, and you can sort of take those different test steps and combine them into one test case. So yeah, we do have like a nice UI to help with that. But yeah, the majority of the test case, you would have to write that in JavaScript. Is a lot of the test cases. Some are in Java.
and then the other question was, is this kind of leading to self-certification, or almost like there's a set that if someone runs and sends the results to you, or maybe you're getting a copy automatically yourself and saying that this is certified?
It's an interesting question. I don't. It does sound like it's going down that path, but I don't know how that will actually play out. I mean, if we did do something like that, we would have to really consider this environment. I mean, how reliable is it, and things like that. I mean, so I don't really know the answer to that question. Somebody here might know the answer to that question, but I personally don't.
I know for a fact we are trending in that direction. We are genuinely, with the advent of the reference automation environment, moving from what it was to what it is now, we are trending in that direction to allow for more self-certification because we can be more confident in the test environment in which the actual certification test will run in. But that also needs a bit of work before we actually can see that into fruition, because we need to know very clearly what the networking environment is, as well as the device environment for the various different various different devices that are connected at the same time. So we are absolutely trending in that direction, but it's not something that we will see in the absolute near future, but within the next couple of years, I totally believe that that's going to happen.
I would think that Google would have had a similar problem with Android platform, and I know they've done CTS, compatibility test suite, and provided their manufacturers with PDK, platform development kits, and stuff like that. So I wonder if you guys were able to pull some lessons learned from maybe the Android team in terms of like doing this at scale. If there's anything there?
Yeah, and I don't believe anybody on our team has spoken with anybody on the Android team about this specifically, but that's definitely something we should consider. I mean, we're definitely not the only people with this problem, so yeah.
Have you used this to do any fuzzy testing? Any fuzzing?
Fuzzy testing?
Yeah, like generating pseudo-random test scripts and things like that.
Not that I know of yet, but I'd be interested to learn more about what you're looking for exactly.
We can emulate a lot of that with the traffic shaping, bandwidth shaping, and stuff like that. We can emulate at least some network fuzzing, but further than that, we're still investigating.
Okay. Thanks for listening.